taking you mathematics. To start with, my name is Omoribola James, and I will be taking you in SS classes this topic called set and Venn diagram. Set and Venn diagram. Before the end of this lesson, we should be able to know this. I repeat myself. By the end of this lesson, you should be able to know this. 1, the definition of a set. 2, the methods of representing sets. 3, types of sets. 4, the different operations that we have on sets. Quickly, I will go over those objectives one after another. The first one, and that is the definition of a set. And what is a set? Now, as written on the board here, a set is a well-defined collection of objects. It's a well-defined collection of objects. And these are examples of sets. For example, set of planets in solar system. Another one, number 2, set of colors of rainbow. Now I go back to the definition. If you look at the example I gave you, you will discover that the members of each set, or what I mean by member is what make up each set, whether in first example or the second example, are well-defined objects. They are not ambiguous or uncertain things. They are things that are well known to us. For example, in the first one, set of planets in solar system, everybody knows that solar system is made up of planets, 8 planets in it. And these are well known, starting from Mercury to Venus, to Earth, to Mars, to Jupiter, to Saturn, to Uranus, to Neptune, and to Pluto. All these are known. Then the same thing, if you look at a set of colors of rainbows, we have 7 colors in rainbow. That is red, orange, yellow, green, blue, indigo, and violet. These colors make up the set called set of colors of rainbow. All these are well-defined things that we know. And these are examples of set. And so that's the reason why we say set is a collection of, or is a well-defined collection of objects. Now, having known that, let's go to methods of representing sets. We have different methods of representing sets. The first one is by description with words. For example, set V is equal to, or is, set of vowels in English. Instead of you writing those vowels out, we have used words to describe the set. That is one way of describing set. Then another one is by listing the elements of the set. The same example I gave you before in this one, we can write it, we can list out the elements like this. Set V is equal to A, E, I, O, U, stating the vowels in English. That is another way of representing set. Then the third one is by diagram. By diagram. If you look at this example given, set S is set of shapes. Or let me say set of plane shapes. I gave you some of the examples of plane shapes. The first one is what? A triangle. The second one is what? A rectangle. The third one is what? A circle. That's another example of how to represent sets. Then we have another method of representing sets. We can also represent sets by using set builder system, or we call router method. In this one, we use some notations. For example, set S is equal to set of X such that X is less than 30 and S belongs to natural numbers. This set is a set of counting numbers that are less than 30. Set of counting numbers that are less than 30. So if I want to list out the elements here, I can write something like this. S is equal to, you start from counting numbers that are less than 30. 1, 2, 3, 4, 5, until you get to 29. Then you close everything in a parenthesis. But we will not use this. If you want to describe sets, or you want to represent set using set builder, this is what you write. If you write it like this, you are using listing method of representing set. So we use this one, in representing set using set builder system. So not this. This one is the use of listing method. Now, these are different methods of representing set. There are 4 in number, and I've given you. Then we go to types of sets. Types of sets. We have different types of sets. All of them are written on the board. The first one is empty sets. The second one is singleton. Let me define each of them one by one quickly. As I'm defining, please go with me. The first one, empty set. Empty set is a set that has no element in it. It has no element in it. For example, set of students with 2 S in SS 3 yellow. Set of students with 2 S in SS 3 yellow. That one is not possible. So, no, that set we have no element in it because nobody has 2 S or no student has 2 S in SS 3 yellow. Then, the second type of set is singleton. Singleton set. This is a set that has only one element in it. For example, let's say set A is this, 3. Set A is that, 3. If you look at this set, you will see that the only element that we have in this set is 3. And that is enclosed in the parentheses. That thing that looks like bracket is called parentheses. Then, this kind of set is called singleton set. Then the third one, finite set. That is a set that has limited number of elements in it. That is, you can count the number of elements in that set. For example, let's say set S is equal to 1, 2, 5. The number of elements in this set can be counted, and the elements we have here are 1, 2, and 5. Just only 3 elements, which we can count. This is an example of finite set. Then we go to the fourth one, infinite set. It's a kind of set, or it's a type of set, with unlimited number of elements. In this one, the number of elements in it cannot be counted. For example, set of counting numbers. That is, set containing numbers from 1 to infinity. In that set, we cannot finish counting. Then, the fifth one is equal set. That 2 sets are said to be equal if they have the same element. If they have the same element. If they have the same element. Let me emphasize that. 2 sets are said to be equal if they have the same element. Let me give you over here. For example, if set A is F, like this. F contains this element. Set A contains element E, element A, element R, element T, element H. Then we have another set, let's call it set B. Contains this. Art. Now, if you look at these two sets, you will discover that the two of them have the same element. E is here. Element A is here, element A is here, element R is here, element R is here. The same thing, T is here, T is also here, and H is here, H is also here. So the two sets, set A and B, are said to be equal sets. So A is equal to B. Set A is equal to set B. That is the meaning of equal set. The arrangement of the elements is immaterial, as we could see on the board. Then we go to the sixth one, that is the sixth type, that is equivalent set. Two sets are said to be equivalent if they have the same number of elements. That is, they have the same cardinality. There's what we call cardinality. That is the number of elements that a set contains. Cardinality is the number of elements that a set contains. So if you have two sets that have the same cardinality, then we say the two sets are equivalent. For example, let me give you that one. For example, let's say set A is 1, 2, 3, 4, 5, and set B, just as we have it on the board here, is R, H, E, A, R, T. If you look at these two sets, you discover that the two of them have the same number of elements. Set A has 1, 2, 3, 4, 5 elements. And set B also has 1, 2, 3, 4, 5 elements. So the two sets, though they don't have the same element, but because they have the same number of elements, we say the two sets are equivalent. That is the meaning of equivalent set. Then we have universal set. Universal set is a set that combines all other sets together. For example, in this example I gave you, we'll still get to that later. If you look at the universal set here, is this U. It's represented by this symbol. If you look at it, this set, this combines all the elements we have in this subset, in this set, this remaining set together. If you look at it very well. So a universal set is a set that combines all other set under consideration together. That is what we call universal. Then we have subsets. Subsets are sets that can be derived from another set. Subsets are sets, or let me say subsets are smaller sets that can be derived from another set. Though we have two types of subsets. We have proper subsets and improper subsets. And that will take us to the next one, number 9, proper subset. Proper subset. For example, I need to give you an example over here so that you will be able to understand that proper subset very well. For example, we are given, look at me. Let me just, this. We have set A, 1, 2, and 5. Now, what are the sets that we can derive from here? We can derive 1 as a set. We can also derive 2 as a set. We can also derive 3 as a single set. Then we can derive, by combining them 2 by 2 again, we can derive this from it. We can also derive this. We can also derive this set. We can also derive the whole thing. 1, 2, and 5. We can even derive, if you look at this one, how many are there? 1, 2, 3, 4, 5, 6, 7. We can also derive, let me write one here first. This, you can derive empty set from it, because every set has an emptiness. Then the last one you can derive from it is 1, 2, and 5. Now these are the different sets that we can derive from this bigger set. You can derive all these. Number 1, number 2, number 3, number 4, number 5 set, number 6 set, number 7 set, number 8 set from this bigger set. Now, all these smaller ones, all these sets that can be derived from this are called subsets. But among them, we have some of them are proper, while the other one are not, or is not proper. This from 1, 2, 5, this, and this. They are all proper subsets of this set A. Why this last one? Because it's equal to the original set. Is an improper subset of set A. So that's where we got proper subset and improper subset. All this one, this, and with this are all proper subset of this. But this last one is an improper subset of set A. Then we go to the 10th one, superset. A superset is a set that combines another set together. It's like the father of another set. Then we have proper superset and power set. Let me explain this power set. Power set is a set that combines all the subsets together. Power set is a set that combines all the subsets together. For example, if I gather all these subsets together in a set with a parenthesis, then what I have is a power set. If I combine everything, let me show you here. Let me use this space to show you. If I combine everything, look at it like this. Power set of set A. Power set of set A equal to, you combine all the sets together. Set this one, then this, until you get to the last one, this set. When you combine all of them in a set, then we have a power set. That is that untitled set. Then let's go to operation on set. Operation on set. Operation on set. Operation on set. We have different operations on set. The first one is intersection of set. For example, A intersection B, represented as this, A and B, is the set of elements that belong in both set A and also in set B. The set we can find in both of them at the same time. In both set A, and for example, they are given this. Let's say the universal set is this. This is set A, this is set B, this is set C, this is set D. Now, A intersection B will be equal to what are the elements that we can see in A and we can also see in B, the common element. The common element we can see in A and B. And that will be, 1 is here, 1 is here. So the first element will be 1, 2 is here, 2 is here. Then the second element will be 2, and 3 is here, 3 is here. The third element will be 3. That is the meaning of intersection A intersection B. Then A intersection B, what are the elements that are seen in A that can also be seen in D? And that will be 3 and 3. That was how we got this 3. Then C intersection D, what are the elements that are seen in C that can also be seen in D? And if you look at it, these two sets, they don't have any element that we can see in C and we can also see in D. So this set is an empty set, nothing inside. Then we go to union of sets. A union B is a set of elements that belongs in either set A or in set B without listing element twice. Without listing element twice. For example, let me use this example on the board and get what A union B is and what A union D is and what C union D is. What is A union B? Now, A union B will be the combination of elements in A and B without repeating any element 2 times. And that will give us 0, 1, 2, 3, 5, and 7. That gives us the answer to A union B. Then A union D will be the elements we see in A and D together without repeating any one twice. And that will be 0, 1, 2, 3, 3. Do not repeat the 3 2 times. That gives us A union D. Then C union D will be the elements we can see in C or D without repeating any element 2 times. That will be 1, 2, 3. And that gives us C union D. Then the last one, the last operation on set. That is complement of a set. Hope you are following me. The complement of a set is set A is a set that contains all the elements in the universal set, but not in A. I repeat myself again. Complement of a set. The complement of set A, for example, is the set that contains all the elements in the universal set, but not in A. All the elements in universal set, but not in A. It is represented this way, A complement or A complement, this, either of the two. Now, for example, you are given this. This is the universal set, and this is A. Then A complement will be the elements we have in the universal set that we don't have in A. The elements we have here that we don't have here. That is, it's like we are taking away this from this. Take away this from this. And that will be, looking at that, that will be A complement will be equal to, what are the elements that are here that are not here? That gives you 4, 5, 6, and 7. That is what we call A complement. So later, this brings us to the end of operation on sets. This operation can be explained better using the Venn diagram. So in volume 2, or next lesson, when we meet again, I'm going to teach you how we can use Venn diagram to expatiate this operation on sets. Thank you. God bless you.